This is SciByte, episode 127, for April 22nd, 2014. Hi, everyone, and welcome back to SciByte, Jupiter Broadcasting's weekly science podcast, live on a Tuesday and fresh on a Wednesday over at jupiterbroadcasting.com. My name is Chris, and joining us every single week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Hey, Heather, happy science to you.
Happy science.
So, what are we going to talk about today?
Today, we're going to take a look at marijuana's effects on the brain, an Earth-like exoplanet, the brain's distraction controls, a possible new moon for Saturn, spacecraft updates, curiosity news, and as always, take a peek back into history and up in the sky this week.
Very nice, Heather. Sounds like maybe we have some hazy topics, so why don't we jump into the news? Okay, Heather, where are we going to kick it off tonight?
Alrighty, young adults who use marijuana, even only recreationally, occasionally, show significant abnormalities in two key regions of the brain that control emotion and motivation.
Aha.
So this is the first study to show that even just casual use is related to major brain changes. And what they did was they did some neuroimaging, examined the brain of young adults 18 to 25. In this specific case, they went to Boston area colleges, took 20 students who smoked marijuana, 20 who didn't. 9 males, 11 females. And so they went through, interviews before and after to make sure they weren't dependent upon it, so they can actually get some specific ranges of what they were looking for. And they actually show that the brain structures themselves actually show that the brains were adapting to low-level exposures to marijuana. Now, it was directly related to how many, joints a person smoked a week. So the more abnormality in the shape, the volume, the density in these specific brain regions.
Yeah.
Now, some of them only used it once or twice a week, thinking, that shouldn't be a problem, but it actually says that it's causing changes in the brain even then. What they did is they examined specific regions in the brain and certain brain cell types to look where there was emotion and motivation, and between casual users and non-users. And they measured volume, shape, and density of the gray matter to kind of get an idea of how different each region was affected. And there were two related major things that happened. It was, it was shown that the emotional and those motivational centers were changed. And it sort of fits with some animal studies that have shown that rats were given THCs, their brains completely rewire, form new connections. That it's like when the people are kind of, essentially the brain is trying to almost fix itself. It's almost becoming addicted right away, in a way, but the brain is changing. Now, in animals, this means that the brain's clicking for rewards and stimulation sort of starts tweaking themselves. So it shows that because of those changes, it actually makes the brain not respond to other happy things. Essentially, it means that it's giving preferential treatment to marijuana to kick in the brain's reward centers and things like that. Now, it's important to know this is for young adults, and it even is for casual use. Yes, the chat room asks if they had a proper control to make sure that there wasn't alcohol users and anything like that. That was definitely part of the psychological studies beforehand. To the best of their knowledge, they could control.
Yeah.
It was to make sure that was going to be the major differentiation between the control group and the testing group. Now, in addition, it's kind of interesting to note that, you say, well, people have been using this for years and years and years, during the, quote, hippie days. But during the 60s and 70s, the the THC content of marijuana was only 1 to 3%. And nowadays, it's actually can go to 5 to 9%. So it's actually much higher than it was currently than it was, 30, 40 years ago. So it has gotten stronger. So it's not like you can just specifically say, looking at, people who used in even casually in the 60s or 70s, say, well, what about, now? It's that in itself is changing. The concentration is changing. But it's, even though some states, have it legalized and controlled, it is important to know that even, using it a little bit, it starts to kind of rewire your brain.
Yeah, the brain is an adaptable. I mean, it's so interesting. Like how it will try to balance everything out, and sometimes it changes your structure a little bit to do that.
Yeah.
And this is coming now. These studies are coming at a time now where it's like, obviously, this is a trend that's going across the U.S., and I don't know about outside the U.S. I would like to see a study. It seems like now that it's legalized in Washington and Colorado for recreational use, and of course it's like in something like 18 states for medical or something like that.
Yeah.
It seems like when it's at that level of usage now, it might be worth doing more than 40 people in the control group. I mean, I realize they got to start somewhere.
Well, yeah.
But
in these type of studies, you have a small, group of researchers who say, hey, we're going to do this size of analysis group because that's what we have the money for.
Mm-hmm.
And now they prove that and they come out with it, and then somebody can pick it up and say, hey, here's some more dollar bills.
Yeah.
Do a larger study. Or somebody else comes along and says, I will do a larger study. Work with us.
Right. Your results intrigue me. Let's fund more.
Yes.
Yeah, that kind of thing. That makes sense. Well, good. Heather, any other thoughts on that story?
No, we'll just see where that goes with it.
All right, very good. Well, I'll just take a little minute here just to say, man, what a heck of a weekend we have coming up over at Jupiter Broadcasting. We'll be live Saturday and Sunday from Linux Fest Northwest, assuming I'm over the plague. And we got Alan flying in tomorrow to join us, and we've got a whole crew coming up to join us at Linux Fest Northwest. And even if you can't physically be here with us, we're going to try having the chat room going all weekend. We're going to have the live stream up all weekend. So just as you're doing your stuff, put us up on your Roku or put us up on your XBMC or your computer or your tablet or your phone and just watch what we're doing, because it should be a lot of fun. So just go to jblive.tv. I would suspect you'll probably start to see something on our stream around 10:30, 10 o'clock to between 10 and 11 a.m. Pacific time on Saturday. And we would love to have you join us, because we're going to be chatting with guests who stop by our booth, and there's no reason we couldn't take a great question from the chat room. In fact, I would like to. So even if you can't physically be there, maybe we can still get some questions answered from some experts in the Linux field. So join us this weekend over at jblive.tv. And if you're watching this after the fact, after this weekend, we'll have a summary episode of the Linux Action Show that kind of covers some of the highlights. So even if you can't catch all of our Linux Fest coverage as it's happening, hopefully the real goodies will show up in an edited down version of the Linux Action Show that comes out this Sunday. All right, Heather. Well, with that done, let's head off to the News Bite. All right, Heather, what are we talking about in the News Bite today?
The first Earth-sized exoplanet is orbiting within the habitable zone of another star has been confirmed. By the Keck Observatory and the Gemini Observatory.
A what?
So the Keck and Gemini observatories.
Okay.
So this is another one of those Kepler Space Telescope planets. So it was identified sort of possibly, and then now they've actually confirmed it with some Earth-based telescopes. And in this case, it is a dwarf star about 500 light years away from us. So close in the neighborhood astronomical terms. And it's the constellation Cygnus. It's very dim star. It's about 500,000 times fainter than the faintest stars we can actually see.
Wow.
It's a very cool star. So the habitable zone is obviously going to be very different size and shape than from our sun, because you need that the distance for liquid water is going to be very different.
Yeah.
That has 5 planets, 4 of which are very close in, very hot orbits. And this Earth's planet is in the temperate zone, which means that water could actually exist there. Now, no telescope can actually directly spot an exoplanet of this size and how close to the star it is. essentially what they do is they take all the data and they eliminate everything else that could be. Like, all right, well, we see that there is some dimming of the star, which we saw with Keck. They can go through and take all the data they have and say, no, they can get down to a specific range and say, we don't see any larger planets outside of this range. So they can say, all right, well, it's not that. And so you can kind of start determining in this bubble around the star that we can't specifically see with straight observation. So what they're able to do is take what they call speckle data. And it's image they go at about 400 million miles, so about 4 times the distance between the Earth and the Sun. And they can say, okay, there's no other size of objects within the radius of the star there. And so then they take a whole bunch of short exposures, images, combine all of them together, and it kind of helps reduce the noise from atmospheric turbulence.
Oh, that makes sense.
That's one of the major things between, what makes space telescope, so much nicer because you don't have to correct or deal with any atmospheric turbulence.
Right. Yeah, absolutely.
Which is also why those telescopes like to be on very tall mountains, because that's that much less atmosphere you're looking through.
So they basically get multiple exposures or captures of it and then lay it down over each other and then sort of pull out different bits that each capture gets. And then in the end, they have something that's of decent resolution. Yeah.
So like you're almost figure like, driving down the road and you're trying to take like a video of something in the distance. And obviously there's going to be some shaking.
Yeah.
But what if you treated it as all the frames were separate photos? And now you take them all and you line them up. So you're doing your Steadicam. So it's kind of lining them up in that way. So it's a whole bunch of different, very, very brief images that you all stack on top of each other and line up with the stars, like you said.
Yeah.
So it's interesting because this is one of the first, they all say, hey, this is the first in this, and this is the first in that. And we get a lot of quote firsts. But this is of Earth size. So it's not, a super Jupiter or a super Earth that it's many times larger than Earth. It is Earth-sized and in the appropriate zone. So cannot yet determine whether there is any sort of liquid there or anything in the atmosphere. But hopefully, since this is the, quote, relatively, as I air quotes, the image of the mind, as air quoting around my microphone, so you can see that. So hopefully in the near future we'll be able to kind of pick something else because it is air quotes close.
Yeah.
So it's kind of exciting.
That is really exciting. I feel like it's been like a couple of years of like just exoplanet after exoplanet, discovery after discovery. It's kind of exciting. I guess it's sort of a new generation of space discovery in a sense. We're just finding all these.
Even. Kepler may not be having fresh observations anymore.
Right.
But there is so much back data that now we're starting to catch up and say, it's essentially like there's a whole list of possible things, over 3,000. And now the ground-based telescopes can start going through that list and say, all right, this one looks interesting. Let's go and actually look at that one.
That's really cool.
Get better data on this specific star and these specific planets.
Very good. Very good. All right, Heather, well, watch out because it's time for the 2-Byte News. Sorry about 147. Okay, Heather, what's up first in the 2-Byte News?
All right, the brain's distraction control. What was that? Ooh, squirrel.
Do we have that? I don't think I have that.
I don't know. So there is a new study that reveals that our brains rely on an active suppression mechanism to avoid being distracted.
Oh, no kidding.
By relevant information.
Okay.
So it's not just that your brain can identify anything that you don't need to focus on. It is specifically also that your brain has another system that goes, shush, other stuff. We're not interested in you right now. So this sort of opens up a whole new ability to say, look at specific brain activities. Say, is it something in the environment? Are there genetic factors? Is there some way that we can help with that? There are a lot of people with ADHD. There are a lot of people who check down a list and go, wow, that's all the things for ADHD. Yep.
Yeah.
That's me. I don't know who that could be. There would definitely be Martians like that.
So
But
it's like a break. Like your brain has like an attention break and say, no, slow down, focus, and that break can be broken, like defective.
kind of, yes. So they're thinking that maybe if they can discover that, help decide, hey, what parts of your brain help hit the brake on that, to say suppress those the
Squirrel tendencies.
The squirrel tendencies. There we go. Maybe it could help with people with ADHD, some serious cases where it is very significantly harming for actual daily life, even schizophrenia, things like that. It's any sort of those attention deficit disorders
Right.
that say, hey, can the brain help deal with distraction, help suppress those distracting objects?
Well, I've been told I suffer from ADHD. I see no evidence of that, Heather. I see no evidence of that at all.
No. Well, in some cases, it can actually work to your benefit if, your job is very here or there and you can't.
True.
Being super focused will actually hurt you.
That's true.
If you do a lot of different things, then you're very happy.
If I didn't have ADHD,
flitting about.
If I didn't have ADHD, then how would I be able to operate the soundboard and talk at the same time?
Exactly. But yes, anonymous Asperger's. There are some where I thought about that too, where it's autism spectrum, from Asperger's to any type of the various degrees of autism. There are some people that think is because it's too much coming in. You can't differentiate what needs to be important and what is not, but what could be suppressed. And yes, Eric, it's not necessarily specifically that. And it is separate things. But some in that range, there are some people who believe there is something to do with that.
Yeah. Fascinating. It's always interesting to find out a little bit more on how the brain works, and it always makes me think of the fact that we're just kind of machines in some ways. Now, we do have a little congratulations to
Yes.
Mama Saturn, don't we?
We do. Saturn may be getting a new moon as we speak.
That's a thing that happens?
Yes, well, the rings themselves, there's a bright clump that they see on the outermost edge of one of the A ring. And it could be a moon in the process of being born.
Wow.
Now, it's this large arc of icy material that they see that's kind of clumped. Now, it could be that it's the result of some sort of gravitational perturbation caused by some object, possibly a moon that we can't see quite yet. Maybe a miniature moon sort of in the process of forming, where all of this clump of stuff is going to come and coagulate more. And half-mile wide object, kind of unofficially known as Peggy, Pegggy, as of right now.
Okay.
And there's thoughts that that's how many of the other Saturn's moons have thought to have formed back in history.
Sure.
So it's really exciting that we're actually being able to see this sort of as it goes on.
Yeah. It's not something that'll probably finish up anytime soon, though, right? Probably going to take a while?
No, it's going to be wild. They first spotted this in 2012.
Okay. Very good. Well, Heather, don't look now, but I do believe we have a spacecraft update. So unless something changes, I specifically, in the new studio, put the warp core destruction button away from the spacecraft update. Huh? Look at me thinking ahead.
Oh my goodness.
I know.
I'm going to have to thank whoever moved that button, because I'm pretty sure you didn't move that button.
So what is our spacecraft update?
All right. SpaceX Dragon commercial freighter has arrived at the space station early Easter Sunday morning, April the 20th. Mission was its third cargo delivery mission. Brought 2.5 tons of science experiments. They'll have it there until the 18th of May. 150 science experiments, 5,000 pounds of science experiments, some Earth observing images, the legs for the robonaut, some communications equipment, some gear, veggie lettuce, spare parts, crew provisions, all that kind of thing. But included in this is, we were talking about this last week, the demultiplexer, the item on the space station that kind of went on the fritz. It controls the robotic mobile transporters, the radiators, solar arrays. They have the repair stuff for that. They have a new spacesuit. They have the repairs for the other spacesuit. So now they'll be able to unload all that,
Okay.
get that together, and start going through and moving that spacewalk forward.
Cool. Now, is it? I've heard a little rumor floating around the internet that researchers have maybe gotten some possible models of what the interior of Pluto could look like.
Yes. New Horizons spacecraft is heading towards Pluto. Hopefully it'll be there next year. Now there was recently a paper published that said they believe they have 3 interior models for Pluto, what they think is there.
Okay.
One is pretty much just a rough rock ice mixture. One is clearly delineated rock, then ice.
Yeah.
Or like an ocean in there possibly, where it's because Pluto and Charon, its moon, co-planet, orbit each other so closely, there's the gravity on both of them sort of moving the crust on them a little bit, so that could actually create enough heat to possibly create a small
water layer.
Yeah, liquid layer.
Yeah.
So there's a whole bunch of different, with this goes theories about how Pluto and Charon were formed, what their history was. So when New Horizons gets there next year, they'll be able to see the surface, which will give them an ideas of some tectonic action. Are there plate edges thrust into the air?
So they'll get some close-up shots to have a better handle on some of these theories.
Oh yeah, we've never had any clear imaging of Pluto or Charon. Now with this, they'll be able to get close-up views, and they'll be able to have a much better idea of what exactly Pluto is, what it's made of, possibly how it was formed. The one drawback to all this is Pluto actually does have a bit of an atmosphere, but because of its orbit, the atmosphere sort of freezes to the surface for part of the year.
Wow.
Or part of Pluto's year, which is quite a while. Now, in this case, they're thinking the atmosphere is going to be kind of at the starting point of that. And because of that, it's going to kind of cover the surface of Pluto just a little bit.
Make it a little bit harder.
Make it a little bit harder to kind of figure out what exactly is going on.
Go figure.
But it still will give us much better, clearer idea of what's going on with Pluto.
Sounds like better than what we got now. So that's really
much
exciting.
better.
All right, Heather, are you ready to head over to Mars and do a curiosity update?
Let's go.
Well, not that one. I said we're going to go over to Mars and do a curiosity update. See, I move the button, Heather, and you see what happens.
I know.
Lift off of the Atlas V with Curiosity.
Touchdown confirmed. We're safe on Mars.
All right, Heather, what is our favorite rover up to?
Alrighty, scientists are using and eyeing out some rock layers surrounding the base of this small butte nearby. They're calling Mount Remarkable as a target for investigating. They've been using the orbiter to kind of peer down on where they are, and using the ground-based eyes.
I love that.
To kind of get a better idea. Looks like there is a butte about 16 feet, 5 meters high, close-ish by, that they're going to kind of start really looking at with their imaging data and use the laser to get some spectrographic analysis.
Okay.
And then from that, depending on what they see, they might drive up to it, get some more testing done on it, and then maybe even kind of put it to the next level, and this will be the 3rd time possibly that Curiosity will start drilling into rocks.
Ooh. Usually some goodies come out when that happens.
Yes, so we'll see. We're really starting to amp up into the time frame where it's going to be getting kind of exciting again.
Yes, very good, very good. Well, I got some excitement for you. In the meantime, how about a time machine? Let's go! Woohoo! This is a quick one. I tell you, Heather, if all the trips were this smooth, I'd try and travel all the time. No big deal. All right, so this week the time machine brings us to 24 years ago, April 25th, 1990. Heather, what happened this week in science?
The Hubble Space Telescope was deployed in space by the Space Shuttle Discovery. It was the first major orbiting observatory named in honor of an American astronomer, Edwin Powell Hubble. Now, it was 7 years behind schedule, bit over budget, and of course, many people of us remember the primary mirror was actually flawed.
Yes.
And so it had blurry images. They had to go
Right.
back and
That was a big
make,
deal.
yep. They had to go back and make contacts for it, bring it up on a separate mission,
Yeah.
put some contacts on it, and then it saw very clearly again. But we are still using the Hubble Space Telescope. 24 years later, it is still pumping out those beautiful images. And I'm so happy that one of the last space shuttle missions was actually able to get up there and do a little bit of work
Yes.
on the Hubble Space Telescope before it was not being able to get to it anymore necessarily. So
Right, yeah. Yeah, very good. Wow. So there you have it, 24 years ago. Wow, and I remember that. So that's okay. All right, no big deal. That's fine. I'm just going to brush that off.
we're not looking at the how many years ago. We're just remembering that it happened.
Yes. All right, Heather, let me recalibrate the SciByte 2000 so that way we can look up into the sky this week.
All right. On April the 29th, there is a small population of the world who will actually be able to see an annular solar eclipse.
Ooh.
Now, this is going to be the first solar eclipse of the year for all of the Earth. This month is really rare as it is, just because of the way the moon is laid out. Most of the shadow is actually kind of hovering above the Earth.
Okay.
But, I mean, of this type of specific eclipse, between 2000 BCE and 3000 AD, so only like 1.7% are of this specific variety. But so only some people in the Arctic. There are several southern Indian Ocean islands. All of Australia will be able to see part of it. Some islands in the southern Indian Ocean will see about 55% of an eclipse sun.
Okay.
In Australia, Perth will be able to see about 55%. Sydney will be able to see about 50%. And it'll be low to the horizon in the west at sunset. If you are in any of those areas, don't forget to view your solar eclipse very safely. Links in the show notes on how to do so.
Right.
And definitely tweet
Yes.
to us.
Yes.
Should you be able to see it.
Please do. That would be so cool. We love
For
that.
our small population
Yes.
of the Science Hearing Network,
Yes. We love
you can
seeing that
actually
stuff.
be able to see it.
Yeah, and then you can share it with the rest of us.
Yes. Otherwise, for the rest of us not so lucky peoples, on Friday, April the 25th, around dawn, look for the thin crescent moon low in the east, and it'll be to the left of the planet Venus. On the whole this week, Venus is our morning star. Look to the east to southeast as daylight reaches us. Mars is our other favorite planet. We were just passing opposition a few weeks ago, which meant that it was completely opposite of the sun. So we'll be able to see that. We can still see that most of the night. In the evening, it's in the southwest with Spica just below it. And they'll be at their highest point around midnight daylight savings time. And moving just towards the northeast as dawn approaches. That's always a good pair because Mars is orangish red and Spica is that blue-white star.
Yeah.
We've got Jupiter. Ding. At twilight, it's high in the southwest, sinking towards the western horizon as the night progresses. And Saturn, with its possible new moon. At the end of twilight, you can see it high in the south around 2 a.m.
That's actually not that bad of a sky. Really. I mean, we don't get any cool eclipses, but as, you know, you got the heavy hitters, Venus, Mars, Jupiter, and Saturn. I'll take that.
Yep, we got a whole smattering of our planets throughout the night.
Yeah. And as always, Heather has all of those listed in the show notes. Just go over to jupiterbroadcasting.com, look for SciByte 127, and everything that Heather talks about is listed out in the show notes in chronological order. So if you just scroll down to the bottom, guess what's down there up in the sky. So if you see something and you're like, what the heck was that? That's your quick check. You just go check that real quick. And you can also send that over to folks. Just copy and paste it and maybe send them a link to the SciByte program to help spread the word about the happy science. Well, Heather, I think that just about brings us to the end. Is there anything else we need to cover before we go?
Not that I can think of.
All right, very good. Well, we'd love to hear from you. Go over to jupiterbroadcasting.com and click on that contact link and choose SciByte from the drop-down. Or you can tweet right at Heather. She's JB_Mars_base. And don't forget, we do the show live Tuesdays at 7:30 p.m. Pacific over at jblive.tv. Heather, thanks for the great show.
Thank you.
And thank you, everyone, for tuning this week's episode of SciByte. We'll see you right back here next week.